All right, folks, it's Bass Action back in action here. In this video, we are going to introduce a new way of measuring an angle. So instead of degrees, we're going to learn a new measure called radians. And then we're also going to learn how to convert back and forth between a decimal representation and an exact representation of degrees, minutes, and seconds. All right, so let's start up here on the top. And what is a radian? And as you can see up here, it is just another way to measure angles. So it's no different than if we dumped you in the middle of Europe and you had to switch all of a sudden from our imperial system to the metric system and think about distances in kilometers instead of miles. We're going to learn to think of angles in radians instead of degrees. That's really all it is. Now, the definition of a radian is a portion of a circle. Remember, that's going to be our circumference, okay? So it's a portion of our circle that equals the radius. Now, this is often a confusing idea for students because the radius is, of course, straight, but the circle is, of course, curved. Now, in our previous lessons, we talked about arc length. So really what we're just talking about is that the length of the arc is the same as the length of a radius. So what we're thinking is that we would have a length right here of, let's say, r units, our radius, okay? And that length is going to be the same as this length right here. Now, if you're at home and you happen to have, let's say, a piece of string or something, you could measure out a length here and then you could lay it along the circle so it would curve nicely, and you would see that the two matched because this figure has been drawn to scale. So at this rotation right here, we have a length of 1 radian, okay? Now, we're accustomed to thinking of this in terms of degrees, and we're going to get to that conversion in a moment. You can see that there are some other dots around the circle, and each of those dots represent a length of 1 radian. So I could rotate to here and get 1 radian, and I could rotate more, and if I stop here, then that would be 2 radians. If I continue rotating, that's going to land me right here at 3 radians, and you'll notice that at 3 radians, I'm not quite at half the circle. So half the circle is going to be 3 radians, and then this little bit more. Then I'm going to keep rotating, and I'm going to get to here. So I'll have 4 radians now, and 5 radians, and 6 radians. So the rotation all the way around the circle is 6 radians, and then this little bit more. Now, we want to understand how much is this little more on the left and the little more on the right. So we're going to go back to our definition, okay? The definition of a circle says it's a portion of the circle, so that's circumference. So let's recall our definition of circumference, which is 2 pi r, okay? Now, if we define our radius as 1 unit, okay, then we can do a substitution and see that the circumference of our circle is 2 pi. Well, we know then, so then our rotation all the way around, our length of our circle all the way around is 2 pi. And since pi is 3.14, we can approximate that as 6.28. Now, sure enough, there it is. There's our 6 and our little bit more, our 0.28. So now let's think in terms of half the circle. We said that when we rotate it around, if we only go half the circle, well, if the whole circle is 2 pi, then half the circle is 1 pi. That's, of course, going to be an exact number, and pi is 3.14, so that's going to approximate as 3.14 then. So we've got our 3 radians, and our little bit more that's right here is 0.14. And again, if you had a piece of string and you could measure it, you'd see that this little piece here is half of that little piece right there. So now we know what a radian is. So remember, our half of our circle is going to be pi. That's our 3 radians. So we're going to have to think of this in terms of this nice exact number and an approximate number. You're going to want to get comfortable thinking in terms of both of those. Let's summarize these numbers down here. Half the circle is going to be pi radians, and half the circle we know from our past is 180 degrees. these two values are what we're going to use to practice moving back and forth between the two types of notation. So down here, we're going to do a little conversion. Now, there's lots of ways to do this, but I want to go through this in terms of a proportion because I think it's going to help us and help many of you more when we get to problems that are going to be over here, like example B. Okay, so the first one, it's probably not going to be quite as necessary. It's a little nicer to see on that next one. So when we want to do this conversion, we can set up a nice proportion using the values from up above. Okay, I'm going to think of the left side of my proportion in terms of degrees. So I know that half the circle is 180 degrees, and the right-hand side is going to be in terms of radians. And since half a circle is 180 and half a circle is pi radians, I can now set up my proportion. I am told that I have 50 degrees that I'm trying to convert to radians. So I'm going to put my 50 here on the left. I'm going to put in X for what I'm trying to convert this to. Now I'm going to do a quick little reduce on the left, little cross multiply, 18X, 5 pi. You could probably do this in your head. So X is going to be 5 pi over 18 radians. And that would be our exact value. And then if you needed to do a decimal approximation, you could, let's say, approximate the pi is 3.14. If you don't have a calculator, just call it a simple 3, and you could see that you'd have a 15 over 18, so it'd be a little less than 1 radian. Now, over here for this next one, notice that my radians doesn't have this pi in it. So I've got 3/8 radians. So that's going to be a little less than a half of a radian, okay? Now, let's set this proportion up. Again, we'll have 180 degrees is the same as pi radians. This time I want the degrees, and I'm going to drop this 3/8 in there, okay? Now when I go ahead and I cross multiply, I'm going to have my x pi, and then I'm going to have 3/8 times this 180 over 1. Make it a little cleaner. We can multiply both sides to get rid of the pi over here by a 1 over pi. Don't try putting fractions inside fractions. That's just going to mess you up. So I'll have that 1 over pi here. If I want to keep this in exact terms, that means that I'm going to need to reduce all of this over here and then multiply straight across. So my 8 and my 180 are going to reduce to a 2 and a 45. And when I multiply then that all the way across, I'll have 3 times 45. That's going to give me my 135. And my 2 pi in, my 2 and my pi here. So I'll have my 2 pi. So I got a little distracted there. So I'll have my 2 pi, and then this is going to be my answer in degrees. Now, it looks really weird, so if you had a calculator, you could type that in, and you would get a decimal approximation in terms of degrees. Then the last thing that we're going to do is this new idea of degrees, minutes, and seconds. This is just going to be a more accurate way of denoting an angle measure. We won't worry about these in terms of radians. We'll just do degrees, minutes, and seconds. So we're going to think 1 revolution, remember that's all the way around a circle, is 360 degrees. Then each degree is going to be broken up into 60 minutes, okay? So we'll have 60 minutes, and this little notation right there stands for minutes. And then each minute is going to have 60 seconds in it. And that little notation there is going to stand for seconds. Now, when we want to convert something, let's say you have this nice exact degrees, minutes, and seconds, and you want to convert this to a decimal. What we're going to do is we're going to convert each point, or each part, I meant to say. So we're going to take our minutes to a decimal approximation of degrees. So we have 12 minutes, and we know that there are we know that we have 60 minutes in each degree, so we're just going to take a 12 divided by 60. We could reduce that. Let's pretend you don't have a calculator. You'd reduce that to 1/5, and we know that is a 0.2. Now, oftentimes I'll have you do these with a calculator because the numbers will just be strange. If I want to do seconds, oops, I don't know why I wrote a G there. If I want to do seconds, if I want to do seconds to my degrees, then I'm going to take my 36 seconds, and now I need to do a little combining. Okay, if I have 60 seconds in each minute, and each minute has, or then there's 60 minutes in each degree, I'm going to use both of these to go from seconds to degrees. So now I'm going to divide by 3,600. I can reduce that to a 1/100, which as a decimal would be 0.01. Now, if I combine all that, my final answer will be 70. The whole number stays just where it was. And then I simply add these two values together. So I get 0.21 degrees. So there's going to be our decimal. Now we're going to go the other way. This one actually I think is actually a lot easier. Again, we get to ignore the whole number and we're just going to work with this decimal. If I want to go from degrees to the minute, so now I'm going the other way, I'm going to take that decimal portion, that 0.628, a calculator is handy here, I'm going to multiply this time by 60 and I'm going to get a new decimal. In this case, 37.68. So if you type that in your calculator, that's what you'll get. We're going to save the 37. That'll be our new minutes. And then we're going to grab this decimal portion and we're going to use just the decimal portion. We're not going to round. We're going to take that decimal portion in minutes and take it to seconds. So now we're going to do 0.68. Remember, just stealing this 0.68 from there. We're going to multiply that by 60 and we'll get a new decimal, 40.8. And now you can go ahead and round that value for your final answer. So we have our original 38 degrees. Then we have the 37 minutes that we just calculated. And then we can round this last number to get 41 minutes. Okay, again, keep in mind, you're probably going to want a calculator for most of these. If we don't let you have a calculator, then it means we're going to make the numbers something that'll be really easy to multiply out. But most of the ones that we'll be doing, I will let you have a calculator handy for those.